In today's video, we're going to be exploring quadratic relations. Let's jump right in. We've got our learning goals here, so by the end of this video, you should be able to understand the key terms and label the graph of a quadratic relation accordingly, create a table of values for quadratic relations, and calculate first and second differences to be able to identify if the relation is linear or quadratic. We've got a handful of key terms today, so you might want to pause the video here and copy them down. I'm going to just read them out loud for you as well. So quadratic relation is a relation whose equation is in the form of y equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. The parabola is a graph of a quadratic relation, which is U-shaped and symmetrical. The vertex is the point on the parabola where the curve changes direction. The maximum is if the parabola opens up, and the minimum if it opens down. The axis of symmetry is the line that divides a figure into two congruent parts. In this case, we're going to be dividing the parabola. And first differences are the differences between consecutive y values. We're going to explore first and second differences in this video. Let's start with our first learning goal here. What I want you to do is to be able to understand some of the key terms that we were talking about in the previous section of this video. So let's put up a rough sketch of a parabola. Okay, and let's also put up some of our key terms, more of a paragraph form here. So the graph of a quadratic relation is called a parabola. A parabola has a minimum or a maximum point called the vertex. All parabolas are symmetrical, and the axis of symmetry is a vertical line drawn through the vertex. So if I put this up here, you can see that I've drawn two different parabolas. I have one opening upward and one opening downward. Okay, so the one that's opening upward, which is the one on the left, has a minimum point, right? It's at the very bottom. That's the vertex. And if we look at the parabola on the right side, the one that's opening down, it has a maximum point. That is the top point of the parabola. There's going to be no points higher than that. Okay? And then the dotted line that I attempt to draw, it's not very straight. That is the axis of symmetry, which divides our parabola evenly straight down the middle. Let's take a look at our second learning goal, which is creating a table of values for different quadratic relations. So let's go ahead and create a table of values for each of these relations. Oh, I need my squared. Boop, there they are. All right, that would be very different if it didn't have this squared in there. So let's start with y equals x squared. Alrighty. So y equals x squared. We're going to create a column for our x and y values. Okay. And what we're going to do is, it's my dog in the background, sorry. We're going to use integer values for x from -3 to +3. This is pretty standard. In fact, this is a parent function, which we'll explore in a video later on. Okay, so in order to make a table of values, all you're going to do is substitute in your x value into the equation and solve for y, and then that will be your y value. Okay, so -3 squared is 9, -2 squared 4, then we got 1, 0, 1, 4, and 9. Okay, let's create a table of values for our second relation, which was y equals 2x squared. So we'll do the same thing again. Create my columns for x and y. Plug in my values for x. And then substitute and solve. You should pause the video here and attempt to substitute and solve on your own, and then you can compare your answers with mine to see if you're on the right track. So for this relation, we've got 18, 8, 2, 0, 2, 8, and 18. Let's do our last relation. Y equals x. Ooh, there should be one more squared here, guys. Always x squared. Y equals x squared plus 2x plus 3. My columns for x and y. Set up my x values. Go ahead and pause the video here again, attempt to substitute and solve, and then compare your answers with mine. Okay, let me share the answers with you now. So we have, make sure I'm on the right layer here. Yep, 6, 3, 2, 3, 6, 11, and 18. Now I know this looks a little different from the other two tables of values. Oh, you can't see it. Let me pop it up for you. There it is. Sorry about that. So it looks a little bit different from the other tables of values, like I was just saying, and we're going to explore why this looks different in our next video when we talk about transformations. The goal here is just creating a table of values for quadratic relations. So all I wanted you to be able to do was substitute and solve. I just want to show you quickly a great website. It's free. It's called Desmos. You could use it for graphing. And I want to show you those relations that we just made the table of values for. If you put them into Desmos, you can actually see how the different values in the different parts of the equation change the way the graph looks. We're going to explore this more in the next video, but I still want you to be able to see it. So the first function we had, which is the parent function, which is y equals x squared. Okay, now in the second relation that we had, it was y equals 2x squared. So you can see that that caused a change here. We'll talk more about that in the next video, but let's put in the final relation we had, which is y equals x squared. What do we have? Plus 2x. And then we had plus 3. Okay, so you can see here that it actually moved. Let me turn off the black one. There we go. So it started with purple, right? We have the 2x, but then we added, we have the 2x squared, but then we added plus 2x, and we added plus 3, and that is how the parabola changes. Okay, so use Desmos and play around with it and explore how parabolas shift and change. I'm just going to try and hide this and see if I can zoom in here and get a better view. So remember that the black one was the parent function. That's what we started with, y equals x squared. And then it changed to the purple, which is y equals 2x squared. And then we also have the red one, which is y equals x squared plus 2x plus 3. You can even pause the video here and check your table of values from the last little segment of our video and see if it lines up with this red parabola. I'll give you a hint right here. I can show you what the vertex is. It's -1, 2. Okay, we're going to explore our last learning goal here, which is calculating first and second differences. Let me just make sure that this is working. Okay, so in order to calculate first and second differences, we actually have to use a completed table of values. So let's go ahead and make a table of values right now for, let me see, let's do this relation here. Let's do y equals 2x minus 5. Now go ahead and pause the video and complete all your y values. Okay, so this is what you should have for your y values. We've got -9, -7, -5, -3, Oops, my apologies. Should be negative 11, then negative 9. There we go. Then negative 7, then 5, then we've got negative 3, negative 1, and 1. Okay, great. So in order to calculate our first differences, we're going to make another column here. Perfect. So here what we're going to do is subtract consecutive y values. So what that's going to look like is we're going to do negative 9 minus negative 11 equals 2. Now we're going to continue to do this for the entire table of values. Next I'm going to have negative 7 minus negative 9. And once again, I get 2. Let's continue. Negative 5 minus negative 7. Negative 3 minus negative 5. 2 again. Negative 1 minus negative 3 is 2. And 1 minus negative 1 is 2. When we see that the first differences are the same, we know that this relation is going to be linear. So we can write that down here. First differences for a linear relation are the same. There we go. Let's do one more table of values. Let's do y equals, I'm just going to draw a line here to divide this. Okay, let's do y equals x squared minus 4. So let's go ahead and draw our table of values. And pause here and check your answers. Okay, let's fill in our answers. We've got 5, 0, negative 3, negative 4, negative 3, 0, and 5. Now let's go ahead and do our first differences. Just the same way that we did before. I'm just going to draw a line all the way over because we're also going to do second differences. Let's get a different color. Okay, so we've got 0 minus 5 equals negative 5. Negative 3 minus 0 equals negative 3. Negative 4 minus negative 3 equals negative 1. We got negative 3 minus negative 4 equals 1, and so on. You can already see, though, that our first differences are not the same. There is a pattern, though. The difference between all our first differences is 2. I don't know if you caught on to that. So when we see that the first differences aren't the same, what we can do is something called second differences. So we're going to use these same values and calculate the second differences. So let's write them out. We've got negative 3 minus negative 5 equals 2. And we've got negative 1 minus negative 3, which equals 2. And then we've got, I realized I didn't put a bracket here. My apologies. We've got 1 minus negative 1, which equals 2, and so on. We can see that our second differences are all the same. So what does that mean? That means that our relation is quadratic. So second differences for a quadratic relation are the same. Whoops, trying to get a different color here for you. There we go.